Yesterday we were talking about graphs of sine and cosine curves. We looked at how to change their amplitude, and we looked at how to figure out what the new period would be if we had a period change, but we haven't graphed any of those with the period changes. We also talked about horizontal and vertical shifts. So just a reminder, the general equation when we're working with a trig function like sine or cosine, this d, you'll notice, could be subtracted over to the other side, so any value subtracted from y is a vertical shift. This a that's out in front of sine or cosine is going to cause an amplitude change. Amplitude is just our maximum minus minimum divided by 2. It's the highs and the lows of the function. A number between the trig function and x is going to cause a period change. We call that b. And we said yesterday that new period would be the original period divided by the b value. For sine and cosine, the original period is 2 pi. That's not the case for everything, but for sine and cosine, the original period is 2 pi, so we would take 2 pi and divide it by b to come up with our new period. And so for example number 3, we've got y is equal to sine x over 2. Might be easier to see that as y equals sine 1/2 x. So what is our b value? 1/2, right. So we're going to take 2 pi and divide it by our b value of 1/2, and we'll end up with 4 pi. We did one exactly like that as our last example yesterday when we were leaving off. So if my new period is 4 pi, how am I going to draw this graph with a period of 4 pi? Well, two ways to think of it. We've said that period is how long it takes for a function to repeat itself. So I need to draw this curve so that it doesn't start repeating itself until it gets down here at 4 pi. So what I can do is I can think about, what does the normal sine curve look like? Okay, it starts and stops with x-intercepts at 0. So I'm going to come over here and say, okay, I know it starts at 0, and I know it's supposed to stop when it gets at 4 pi, so I'm going to give myself little marks there, an x-intercept at 4 pi and an x-intercept at 0. Alright, then if I come back and look at it again, I know halfway between the starting point and the stopping point, I have another x-intercept. So I'm going to come over here and say halfway between 0, the starting point, and 4 pi, the stopping point, I'm going to have another x-intercept right here at 2 pi. So I'll give myself another value there. Then I'm going to come back and look at the original and say halfway between those first two x-intercepts is where it tops out. So over here, halfway between 0 and 2 pi is where it's going to top out. And then back on the original, halfway between the last two x-intercepts is where it bottoms out. So over here, I can say halfway between 2 pi and 4 pi is where it's going to bottom out. And so I've given myself key points that I can use to help me sketch this, and then I can just go back and play dot to dot to create my graph. Now, two ways to look at that. I have drawn the sine curve so that it doesn't start repeating until it gets to 4 pi. So that's the idea of period. But this second definition down here is really helpful for me. It may not be for you, but it really makes sense to me. If I think of b as the number of cycles that I'm going to put in the same amount of space I would normally put 1, my b value was 1/2. So I'm going to say, okay, I'm going to put half in the same amount of space I would normally put 1. What does half of the sine curve look like? Well, here's the first half of it right here. It's just like a semicircle, right? It's like the top half of it. So what I want to do is I want to draw half of the curve in the same amount of space I would normally put the whole thing. And so I could say, okay, from 0 to 2 pi, I'm just going to put the top half of this thing. Then that sets the stage that, okay, I'm going to put the bottom half of it from 2 pi to 4 pi. So whichever one of those clicks for you or makes more sense for you, we can use those to help us change our period. So you'll notice that a period change causes a horizontal stretch or shrink. Vertically, I did not move. I'm still going up to 1 and down to -1. So it's just causing a change horizontally as a stretch or a shrink. Now, we're going to start putting together all these ideas that we've looked at. Amplitude, period change, shifting, reflecting. We need a particular order, and here's the order they're going to go in the book. They're going to go in alphabetical order. So they're going to start with A, which they're using amplitude change for A, and then B, they use period change, and then C, horizontal shift, and then D, vertical shift. Now, you'll remember from when we did shifting before, we learned that if we had a shift and a reflection at the same time, we had to horizontally shift, then reflect, then vertical shift. So in between C and D, I've inserted another step there to be sure that we would do any reflections in between horizontal shifting and vertical shifting. Okay? So that's the order that we're going to follow for each of these, and I've got it here on the board for you as well. We'll leave it up here so that as we're doing problems, we can refer to that. All right, so example 4, they start asking us to do a couple of these things in combination. For example 4, we've got 1/2 sine x minus pi over 2. So we can start off with, do we have A? Do we have an amplitude change? Yes? No? Maybe?
Yes.
Yes. What is our amplitude change? 1/2, right. So we could say A is equal to 1/2. Now, I have some students that confuse a vertical shift with an amplitude change. They look very similar. When you've got a 1/2 out in front of the function, here's the way to tell the difference. In order for me to be able to move that 1/2 over to the other side and it be a value subtracted from y, it would have to be 1/2 plus sine x for it to be a vertical shift. For it to be an amplitude change, there is no sign in between the 1/2 and the trig function, meaning it's being multiplied. I'm not going to divide it over to the other side to vertically shift it, right? I'd have to subtract it over. So that's an easy way to tell the difference. So absolutely, this is an amplitude change of 1/2. So I drew the normal sine curve on here so we'd have a reference. You don't have to do that, but let's draw that sine curve with an amplitude of 1/2. So go ahead and do that on your paper right now. Draw your sine curve with an amplitude of 1/2. That's what we worked on yesterday. All right, so here's our sine curve going up to 1/2 and down to negative 1/2. So it caused a vertical shrink. All right, what's that pi over 2 going to cause? Horizontal shift, exactly. So I've got a horizontal shift of a positive pi over 2, horizontal shift right pi over 2, whichever way you want to think of that. Now, some of you are really visual people. You can look at this and see how to move that red graph pi over 2 to the right. If not, if you would like some points, like some guide points to go by, you can do that. Literally, all I would do is take my red graph and say, okay, I'm going to take this point right here and bump it over pi over 2 and give myself a new point to draw. I'm going to take this point right here and bump it over pi over 2. I'm going to take this point right here and bump it over pi over 2. Take this point over pi over 2. This point over pi over 2. This point over pi over 2. So again, if you need to go through and move point by point, then you can just play dot to dot. Melissa, would you catch one of those lights? Thanks, babe.
Which one?
Doesn't matter. Perfect, thanks. Now, in your textbook on 327, they give you some formulas. I don't use these formulas. I'm not going to require you to know them, but just in case they would be helpful for you, I didn't want to skip over them. In the middle of 327, they say, if you want to know where your first cycle is going to start and where it's going to stop, you can use these formulas right here. So if we look at the one that we just had, in between sine and x is our b value, so we just have a 1 there, so b would be 1. And then our c value was pi over 2, so we would have 1x minus pi over 2 equals 0, and if we solve that for x, we'll add that pi over 2 to both sides, we'll get x equals pi over 2. That tells me that my first cycle would start at pi over 2. And sure enough, if you look at our answer over here, that first cycle started at pi over 2. The second formula tells you where your first cycle would stop. So again, b was 1 and pi over 2 was c. So if I add the pi over 2 to both sides, I'll end up with x equals 5 pi over 2. And that is where our first cycle stopped, right there at 5 pi over 2. So you don't have to use that. It's not going to be on the test. But if it helps you to see where to start and stop, then please feel free.
So you don't go all the way through pi?
Usually they're going to ask me to draw 2 complete cycles of this. And so like the first cycle would go from pi over 2 to 5 pi over 2, and then the next one would pick up at 5 pi over 2 and keep going over here. So you can extend it, you can draw 4 complete cycles if you want to, just extend it as long as you want to. All right, look at example 6. For example 6, we've got y equals 2 plus 3 cosine 2x. All kinds of crazy stuff going on here. So let's start with A. Do I have an amplitude change? Yes. What's my amplitude going to be? 3. So I drew the cosine on here for you to have a guide. You don't have to draw that. But using that guide, go ahead and draw your cosine curve with an amplitude of 3. Draw your cosine curve with an amplitude of 3. Alright, so normally cosine starts at 1, but we want to start at 3, come down to negative 3, and come back up to positive 3. So there would be 1 complete cycle, and then we could keep on going. Alright, what is our b value? What's our b value? 2, right. So we are going to have a period change as well. So if we're going to figure out our period change, remember yesterday we said our new period would be equal to the original period, which in cosine is 2 pi, divided by b. So since our b value is 2, we're going to do 2 pi divided by 2, and that'll give us 1 pi. So let's come over here on the side for just a second. And, leaving all this stuff over here behind, we've got to do 3 or 4 things over there. Let's just focus on what would a period change, cosine 2x, what would that look like since period change is new for us today? Let's just focus on what putting a b value of 2 in would do to the normal cosine curve, and then we can start putting it in conjunction with all the other stuff going on over there. Okay? So if my period is pi, that means that by the time I get to pi, I got to be done drawing this thing. Or I can think of it, if b is 2, I have to put 2 in the same amount of space I would normally put 1. So normally I have 1 done by the time I get to 2 pi. I'd have to have 2 done by the time I get there. So I'd have 1 done by the time I got to pi, and I'd have the second one done by the time I got to 2 pi. All right, let's use some landmarks again. If I look at the normal cosine curve, it starts up and it ends up. So I could say, okay, for my curve, it's going to start up. I know it's got to end by the time I get to pi. It's going to end up. Also, when I look at that original curve, halfway in between the starting point and the stopping point is where it bottoms out. So for mine, halfway in between the starting point and the stopping point, I'm going to have it bottom out, and that's what my curve would look like. So there's 1 complete cycle. A lot of times they'll ask us to do 2 complete cycles, so there's 2. So whichever way you looked at that period, I have to be done by the time I get to 1 pi. There it is. I'm done by the time I get to 1 pi. Or I have to put 2 in the same amount of space I normally put 1. Okay, there's 1, there's 2 in the same amount of space I normally put 1. So that caused a horizontal shrink when I put that 2 in there. Vertically, it was not changed. It was still going up to 1 and negative 1. Okay, so let's take that period change and let's apply it back over here to this problem that we were working on. When we stopped, we had already taken care of the amplitude, so we were going up to 3 and down to negative 3. Now I need to draw that red graph so that it has a period of 1 pi. That means I need to draw that red graph so it's done by the time I get right here to pi. So I can go through then and I can give myself some points and say, okay, I know it's going to start up at 3 and it's going to end up at 3, and halfway in between it's going to bottom out at -3. So I've got some guides for myself. And then I can go through and connect those, and once I've got the first one, I can keep going and, give 2 or 3 or 4, however many of these I want to give. Alright, so we've taken care of A, we've taken care of B. Do we have any shifts, C or D, horizontal or vertical shifts, either of those? We have a vertical shift, right. Vertical shift of what? +2. Now, you may not need to do this, but I like to have little guide points so that I can just play dot to dot when I'm done and have it simple for myself. So what I'm going to do is I'm going to take that blue graph and I'm going to go point by point and say, okay, this point on the blue graph, up 2. Make myself a new little green point right there. Same thing, I'm going to take this point and come up 2. I'm going to take this point and come up 2. Take this point, up 2. This point, up 2. And so I've just gone all along here and taken each of my blue values and brought them up 2, and now I've got little green dots that I can go through and just connect dot to dot. And that green graph is my final answer.